So I guess we can just really quickly introduce, this is the Cameroon team, myself and Manfo. And then in the other room, we have Didier and Kala, who is leading the French room. These are our main developers here on the ground. They're super excited about Haskell and then leading into Plutus. And I think some of us have met already from the Education Initiative meetup. But without further ado, Manfo, I'll let you get us started.
Hi, everyone, and thank you again, Megan. Super excited for this wonderful event. It's always hard to kick things off, and once it's done, it becomes in my opinion, super easy. So, very quick, I would suggest we do a round table, whatever it's called, to take a few seconds and introduce ourselves very quick and why we're here today. And then I will get on with the content that we'll be going through today. So starting very quick with myself, Manfo here, Haskell lead at WADA, working in Cameroon with Megan and Didier. And it's been a crazy trip getting here, preparing all of this, and super exciting. So I'm really looking forward for this little group to expand in such a way that in a few years we really become where we are, what we are envisioning. So I will stop there and other people can jump in for a few seconds.
Hi, this is Sydney Nicholas. I am in the Detroit metro area. I am very interested in learning Haskell as well as Plutus and kind of taking that developer journey. I'm here to support Manfo, Megan, and Didier, and just excited to be here.
Thank you, Sydney. Who's next?
I can go. When it comes to passion, Manfo, Megan, Didier, the Cameroon group, they just showcase what passion is. Look at the Ghana group, you look at the Cameroon group, and it's just, it's just the passion that everyone brings. And I know that the success of this, sort of just even getting together and discussing and sort of having this introductory look into Haskell, it's just, even though that's a skill thing and that's a knowledge thing, but I think that the other part of it is the inspiration, the spirit behind what we're doing and the energy that it brings. So thanks for sharing that, Manfo. Very grateful.
Thank you, Mercy.
Hello, my name is Richmond Opong from Ghana, and I'm a graphic designer. I'm here today to learn Haskell, and I'm really excited to be here today because I'm not a programmer though, but I really think I can go through and then pass this course. Yeah, thank you very much. Really excited.
Hi, hello, my name is Efia, and I'm new to all this, but I'm learning hard and praying that I'm going to succeed. I'm actually praying to win the Saturday quiz. So I'm here to learn whatever I can. I'm with the WADA Ghana team.
Hi, my name is Emilia Safo. I'm with the WADA team, and I'm an entrepreneur, and I'm excited to be part of this training. I don't know anything about Haskell. I'm just a beginner, and I'm going to learn more about it and use it for any good thing that I should be using it for. So I'm happy to be part of it. Yeah, thank you.
Hello, I'm Richmond. I'm new to Haskell. I'm hoping to learn a lot since I have an interest in development. I'm a student also. Thank you for this opportunity.
Hello, my name is Daniel from the Ghana team. I have a background in software development, but Haskell is new to me and I'm very passionate about it. I want to learn it. I want to explore more about it. On top of it, I want to be part of those people writing the smart contracts. Thank you.
Hi.
Hello, I'm Ira Ajwa, and I'm a student. I'm new to Haskell and I'm new to programming. I hope to learn a lot to be able to use it in development. Thank you.
Hi, my name is Jeremiah Bani from Ghana. I think I've also been exposed to quite a number of imperative programming languages, but Haskell tends to be a new paradigm altogether. So I think this is an interesting hackathon program you have put up, and I am willing to put in all my efforts to start learning something new in Haskell. Thank you.
Hello everyone, once more, I'm Colin, Professor Haskell. I'm a software engineer with Luminara. I have some experience using functional programming already, and I'm really interested in Haskell. I've dabbled with it before, but I am taking this as an opportunity to really dive in and use it for something practical. So yeah, I'm happy to be here.
It looks like we got everyone here. So great, yeah, thank you very much for the introductions. It's always good to know who we are dealing with. So our next point is really going to be about talking about the goals of this hackathon. We are starting today, but we are hoping to be holding similar events every 3 months at least, and leading into Plutus once we feel more comfortable with Haskell. And we are doing this in parallel with our meetup and the trainer training program in Haskell that has been going on for a few months. So again, this hackathon main goal is really to incite, get people interested into the functional programming paradigm, which comes with a lot of benefits, and in a more specific way, get them interested in the Haskell programming language. The next point is really about making sure that you all got an invite to set up your repo environment, which is the platform we will be using to type our code live. So I will share my screen and make sure that I no longer have pending sign-ons here. Let me see.
Wait, I don't think I've done it yet.
Okay, we'll invite you right now. Can you guys see my screen?
Yes, I can see it.
Yes.
Yes.
Great. So down here, I've invited everyone who signed up for this, registered for this event. where you see can edit means you are okay, and you should just open REPL 8 on your machine. It's just a website, or I can just copy this link and share it. And let me see. 1 second here. So I just shared a link. Let me go back to my screen. And all you need to do is click on that link, and it will take you to the REPL.8 platform. And from there, you can have access to all this code we will be typing in here. You might be asked to create your account if you haven't done it yet. I would suggest you just use your Google account to create one very quick, so that you don't have to deal with the password right now. And yeah.
I have an account, but it's asking me that I need to give it permission or something. I don't know.
So you click on the link and it's asking you to.
I have to give it permission. I've already created the account through the email you sent.
Okay. So, and you just click on the link that I shared, right?
Yeah, and it's saying that it needs your permission to enable notification. I clicked on confirm, but it's not working.
Okay. Let me just.
Okay. I clicked on cancel. It left. It's okay.
Is it good now?
Yeah.
Okay. Are we all set up?
Yes, I'm in.
Okay, I guess we all good. So next, I'm going to start with sharing the program. The content will be running through very quick over here. So on the first point, we'll be really discussing about Haskell. What is Haskell? And I'm already seeing a mini typo there. Haskell is actually 2 L's. So we'll fix that later. Then we will talk briefly about what you need to dive in, REPL.com being one of the platform, on the tools that you need. After that, we will jump to basic types, types being, the tools that you use to actually, or one of the tools that you use to build a program. The program being just a software like you write. We'll talk about like bools, char, talk about numbers. We'll touch a little bit on other like intermediate concepts like constants and polymorphism. We will brush on operations and talk a little bit about what is the concept of inference in Haskell. After that, we'll jump on to the list, where we'll talk about strings and go on with the generalization on lists. And we'll talk a little bit about like list comprehensions and tuples. And once we are done with that section, we will talk about like type variables. And don't worry too much about all these new names. We will go through it. Then we will jump onto functions. Functions being like the main building block in Haskell. And then we will talk about like some constructs that you use in the language, such as conditional expressions, pattern matching, words, where, let, and in keywords, and so on. So then we jump to higher order functions, explain what they are. We will touch carried functions and touch a little bit on some advanced functions on lists, such as map, filter, folder, and make sure we mention the function application operator over here. Function, oops, sorry about that. So then we'll wrap up with custom types and type classes. So what is Haskell? Haskell is really a purely advanced purely programming language that has functions as first class. And functions in the mathematical sense are really a black box, you know, that take in some stuff and do some internal work on them and then return other stuff based only on what they took it. Haskell treats functions as first class, which simply means that functions can be treated as values, values being like something you affect to a variable, and we'll get to that, don't worry. But the main points here are the fact that Haskell really builds on top of functions and types. And also Haskell has the concept of immutability, meaning once you say something is, let's say, blue, it will stay blue forever, which usually doesn't happen in other programming language. In other programming language as well, it's not very easy to pass functions around as argument to other functions or return functions as a result from functions. But we will get more in detail into that. So we did mention that what you need to get in really is a text editor, which is just like an editor where you can type your code, and your code being just words that you write that follow a set some rules and some specific syntax. It has a vocabulary, and you know, you just combine those words, and that's how you write a solution to your problem. So you will need a text editor. It could be a simple one as Visual Code, or you can just even use Notepad or whatever text editor of your choice that you feel more comfortable with. For this session, we will be focusing on using REPL 8, which is, let's say, a text editor online, so that we don't have to worry about like installing this locally. But we'll get to that in our meetups when we start like really working on Haskell. So Haskell, as I said, you basically write lines of code, which are words that follow a given syntax. And Haskell compiler is just, you know, another piece of software that translates all that code that you wrote. It checks it, making sure that you respected the syntax, and it compile it. I would just say transform it here into something that the machine can read. So at the Haskell level, you're writing things that us humans can read in the text editor, and at the machine level, you are basically, Haskell is transforming that into something that the machine can read and understand. And then it can be executed by your processor, or, you know, run. That's another term that is used. So we didn't mention the link in there where you can download like the full, like install your full Haskell platform. And GHC is actually the most used Haskell compiler out there. And you will, once you install the tools from this link, it will install GHC Haskell compiler in your machine. So as I said, Haskell is really about like writing a file. So you think about a problem and then you write the file. Once you have that file, you know, you use some command. The compiler comes with some commands that will allow you to compile that file. Compiling it is basically turning it into some sort of 1 and 0s, the language that the machine understands. And once you do that, you can run that file. So if you look at this capture here, what I'm telling Haskell here is basically to compile all the code that I wrote into this file. And you can see it has a .hs, which stands for Haskell file. And once I do that, the compiler will produce a few couple of files, all name matrix product something. And I can just use the syntax here, this command here, to call that file, the program that I wrote in that file. So, and that's a really kind of tedious way to do this. We don't need to spend too much time on it, but we'll come back to it later. So again, I mentioned the fact that you can use Visual Studio to you know, have a nice editor, text editor or software editor that comes with a lot of functionalities that in future iteration we'll spend some time on. So
I'm sorry to interrupt, but Malfo, should we be seeing, because I'm just seeing the Replit page. I'm not seeing, I'm not sure if you're speaking to us from a different page, but I'm only seeing the Replit right now. So that introduction that you gave, it's been on the Replit page the entire time.
oh, sorry, Sydney, that's my bad. Let me just fix that.
No, that's fine. Okay.
Can you see it?
Yes, I can see it now. Thank you.
Okay, sorry about that. So,
Okay.
and by the way, this document is published on GitHub, and we did provide the link to it in the email,
Okay.
confirmation email. So, are there any questions so far? Okay, well, let's move on with types. So again, in Haskell, one of the core concepts are types, and types really are a way you organize things or you group things that have similar functionalities or operations. So in the world of Haskell, when you think about like a person in real life and you want to conceptualize that into your software, you use types. So you basically create a type that reflects, you know, all the attributes and characteristics of that object in the real world. And one thing to highlight here is types in Haskell are really different from what we have in object-oriented called classes, because classes actually give you, you know, objects that things you create from classes that represent the real world stuff are actually mutable. So meaning you can create something now that has like a set of attributes and characteristics, and a few hours later you change some characteristics, some of those characteristics within your software. In Haskell, that is simply not possible. Once you create a type, once you declare and create a value from a type, it stays like that forever. So in Haskell, things that you create from type, type being like your, how can I say, like when you are making, let's say, a cake, for example, you use those little balls. I'm not remembering the word, but they are basically what types are. So you make that, you have that little ball, and you can just make a cake out of it. So types in this context would be that ball, which is like your, let's say, your sample, the thing you use to make a cake that have some shapes. And then the cake you make out of it would be like the values that have that type, the values that have that type. And in Haskell, the way you say a value has a given type is you use these 4 dots. And let me make sure that can you see my repo?
I'm still seeing I'm seeing the document that you were reading from.
Okay, so I guess I need to share my entire screen here. How can I do that? I don't have to go back and forth. Well, for now, I'll just share this. Now you can see my repo, right? Okay. So again, remember, we just talked about like Haskell being just, a Haskell program being just a file that you write with some instruction in it. And basically it solves like a given problem. So here, for example, on this platform, I create a file called main.hs and all Haskell files end with .hs. And in here, the function here is a function that does something. We'll come back to that. Don't worry too much about that. But what I really want to show here is this other window here, the shell. Give me 1 second. Which is where I can load up this Haskell file and then run whatever thing I wrote in here through it. But before we get there, I need to show you how to get into the Haskell compiler, which is the guy that actually run all of this. So the command is ghci, and here you get some information about the version, not very important, but that prelude is telling us that we are into the Haskell compiler. So once we are in here, we can say stuff like A. So we are defining a value. So we can say stuff like A equal 5, and it has type, let's say an int, which is just a number. Int is basically a number. So I'm going to type that, and at this point, I've created a value that I call A, and its type is int, and I've given it 5 as its initial value. And remember, we still have that forever. So again, in Haskell, this guy here, these 4 dots, indicates the type of a variable. Another way, if we come back in this file here, would be to say something like name as type, string. So name equal, let's say, Felicien, has type string. So over here, I am creating a value whose name is name. I'm affecting it this, so it's kind of a one-on-one binding. Then I'm giving it the type string over there. So to resume here, these 4 dots really tell us like the type of a variable. And once we have a variable living in the compiler, if we want to figure out like what type it is, we use the syntax. So we type type, and then we type the name. So in this case, A, and as you can see, we get back A has type int over there. Are there any questions so far?
I have a question. So when we're on this replit.com and typing in the dark blue side, is everyone sharing that, or are we all on our own things?
So we do have, we all, I mean, those who are connected, here you can see +6. So those are the people who have access to this file. And, you know, whatever I type in here and I run it, it will show up into this tab here, which is your console. So let's see. There is a little bit bad over here. So what we could do here is let me. So if I run using this button here, you should all see hello all on your screen. But yeah, we'll get more into details on how we can use this as a group once we get to exercises. Does that answer your question, Nick?
Yeah, I think I'm not in the file, but I'm in Replit, so it's okay.
Okay, I'll make sure to fix that during the break. Okay, so let me go back to here. So again, we just learned about like that operator there, what it does. Very simple. It just says a given variable has type, a specific type, a given type. So in Haskell, we can construct our own type to model concepts in life, as well as we can, you know, the Haskell compiler do come with a lot of like pre-built types that we can then use or combine to build even bigger types. So one of those basic types is bool, which stands for a Boolean. You know, we all know about like the concept of true or false. So this type here groups all the values that are either true or false. So if you remember, we saw this command a few minutes ago, and we said, if you want to figure out like the type of a given value, you just have those columns and you append T in front of it. and it will tell you what that value is actually. So if we do this, sorry guys, I haven't figured out how to, it's a little bit annoying to have to share like this. Let me see, computer, easy, share. Okay, well, I'm gonna have to go back and forth for now. So again, we just talked about bool as a basic Haskell type, and its value, the values bools can take are actually true and false. So if I have, let's say, a variable called a, or some sort of result, I could say my result is equal to true. And at that point, the type of result has type true, bool instead. So to double check that, if we come back in here and to enter the compiler, I go JHCI and I write result as a result of some sort of program or something I'm writing, and I give it the true value. At this point, what I can do is try to figure out like the type of result. So when I do that, and you see I get result has type bool. So bool is the type, the basic type in Haskell that holds true value, either true or false. So very quickly, we can go with result equal false. And if we go back to the type of result, and then we get bool. So let me go back very quick. So that's all about bool. Now in Haskell, we have another basic type, which is called a char, which is used to represent character data. So basically, if you want to declare, let's say, the character A, you just use the syntax here, which is actually very simple. So again, you can run this in the Haskell compiler.
Hello, Manfo.
Yes.
Yeah, please, the bool. Can you give us like a scenario, like an example or a syntax that either the results should come out to be true or false, like so that we see how it works? Maybe 5 is greater than 3, true or false, so that we can get it how in a real life scenario.
Yes, absolutely.
Okay.
So let me just bring back this over here. So I'm going to go back to the repo. So let's say we have a function that takes 2 numbers, and we'll get to the definition of the function, what it does. Let's call that function compare my numbers. And this function, remember we talked about the has type. So when you are defining something in Haskell, you can give it a type. So it takes on a number called int, And we'll come back to the syntax later. It takes another number and it returns either a bool. I mean, it returns a bool. You know, let me come up with a better thing. Are they equal? So we have a function that takes two numbers and tell us whether they are equal or not. And so that's its definition. And we'll come back to the syntax. So that's an integer there. It takes another integer and then it returns. It does some work with these two integers and it returns a Boolean value. So now, how does this function work? So we'll take like, let's call it value 1 and value 2. And then what's going to happen? So I will literally do if value 1 is equal to, let me just do this. So I will do if value 1 is equal to value 2. Oh, sorry about that. Value 2, and then what you need to return is true. They are equal. And else you return false. So that's how you, that's a concrete example of how you would do that. And so what we could do is we can now run this, and we are getting an error there. Let's see. Okay, there's an issue there. So what I would do,
Could it be that the repository is seeing the function as being under the main block because of the do?
oh yeah, it's that. So we have a thing here. So Haskell is very picky with these you know, spaces here. So what's actually happening, just like Asen said, you know, I had a space there and it was looking at this as something that was within the main context. So if we go back to that, and thank you, Asel, and we rerun this. So then we have a problem here. That's my mistake. So if value 1 equals value 2, then we get true, else we get false. So that should be good now.
Marco, why don't you pass value to the variables that you have created? The var1 and the var2, I think you should pass values to them.
Yes, so you pass value to them when you are calling this function. So at this point, and we'll get into it, we have defined the type of this function. You know, saying it takes an int, another int, and returns a bool. So now we have that function here that could take any int. It could be 1, 2, 3, 4, 5. Value 2 that would take like this and return that. So we are missing an equal there. Does that make sense? Finally, so here we have you know, our function are equal in memory. So if we go there and we, sorry about that. It's actually in here. So again, you have to call the GHCI to start the Haskell compiler. And then you can use this command to see what files you have. They're listed there. We have main, we have all those folders. So our code is written in main. So what I'm going to do here is I'm going to load up that file. So it's load, that's the command. And I'm going to give it the file name. So at this point, this code that I've written in this file is living into my Haskell compiler or repo. That's how it's called too. So how do I execute this function? So I just copy it from there. I paste it there. And let's say I can ask myself whether 1 and 2 are equal, and then I should get false. And if I was to do 1 and 1, I should get true. Does that answer your question?
Perfect.
Great. So any other question on this aspect?
So I have a question for you, Manfo. So in line 6, what you did there was create a type. And then in line 7, 7 and 8, that's a function. And then in the shell there, you just call the function.
Exactly.
With 2 values.
Yep. That's correct.
Okay.
Okay. Cool. So let's go back to the lesson. So that was it about bool. Char is basically the same concept where you have things that it's a way to conceptualize or represent characters. Characters being stuff like A, B, C, D, or digital characters like 1, 2, 3, 4, 5, and so on, and even like some symbols. It can get a little bit complicated when you are using numbers to represent characters, because each in Haskell, each character in the alphabet specifically can be represented with numbers. So you just have to use this symbol and do slash like that and put that number in there, and that's basically A. Or you can use hexadecimal representation for the numbers, and you have to use that empty slash there with an X, and then the hexadecimal code. So again, once you have the way you declare character is really like putting it into single quotes, just like that. And here you see we are using that command we saw previously, what's the type of A, and the compiler is telling us that A is actually a character. So characters do come with a lot of functions in them in the package, and by here package, it's just a way that has a group some functions for some utility functions for a given type, like in this case data.char is a package. It's called a package, and it basically has a bunch of functions that help you run some some code or some action, some functionalities on characters. So here, the function to oper is part of that package, and you can check the type by using column T to oper, and you see oper takes a character and returns a character, uppercase character. So very quick, we can test that in our repo. So 1 second there, so we share very quick. So here, if we go into our record and we import data.char, it being a package that has a lot of functions that we can use on the data type char, the type char. One of them being like toOpera, and we can use that syntax to figure out like its type. It takes a character and returns a character but in uppercase. So I can do something like toChar, toOpera instead of, let's say, A. So then it will return A that way. Or the other syntax that I mentioned is you can do toOpera 97. It's another way you can represent the A character. Or, you know, and same thing for hexadecimal. So any question on this point? Okay. So that was it for the char data type, and I invite you to look at this ASCII table, which has all the codes, hexadecimal codes that I mentioned for each character, or numeric corresponding values for characters. Haskell comes with numbers, and we did see int already. Int is a way to really you know, capture or conceptualize numeric value. You do have int, which is bounded, meaning like it's limited. So, you know, it's either a positive number, this that you see there, not sure if I can get that right, or a negative number. So it's kind of like an interval. Integer is an unbounded type, which means that you can represent numeric value as big as you like, as long as your machine can handle them. That's the only constraint here. And Haskell do have other types like float and double to represent number with you know, decimal parts, and that's all about numbers. So we touched base on int. I mean, we talked about int. Integer is basically the same thing, except that you can have arbitrary large numbers. Float and double are numbers that come with a decimal part. Any question on that?
So the only difference between int and integer is the size of the number that you can use there.
Exactly.
Okay.
Okay. So let's move now to constant and polymorphism. So here, you know, when we get into the compiler and we ask him what's the type of 5, he really doesn't know what to tell us, because 5 could be as well as, you know, could be an int. You know, it's a number, so it could be an int, could be an integer, it could be yeah, it could be one of those. So the compiler looks at it and say, oh, you know, I'm going to give you something called a type variable, because in this case, the 5 that you're asking for a type could actually be multiple types. It could be int, it could be integer. But all I know is that that thing, that number you gave me is constrained by something called a class. And here in this case, we have num, which basically says that whatever this A is, it is, oh, that's great. Someone is having fun here. So whatever that A is, it is a num, meaning that it's something that is either number or it's something that is either in int or in integer. So that
Not sure what happened, but I just lost you, Manfo. Yeah.
okay, so it's strange, but I'm gonna go back and share my screen. So we were here talking about like this syntax here. So Haskell tries to give you, you know, the biggest type you can have, the biggest type possible, in the sense that when you ask for the type of file, he's telling you it could be an integer or an int. So I'm not gonna pick one of them, but I'm gonna give you the flexibility to constrain it with something that actually includes those two types. And then later, you know, you can choose a specific type for that variable. It's the same thing here. So if we run type, the type of 3.4, which is a float, which could be a float or a double, you know, being a decimal number, we get this constraint fractional. Fractional is a class. It's called a type class that could actually, that indicates that A could actually be a float or a double. So what these are type classes. These are called that way. So it's a type class, and what it does is it allows you to group you know, set of types that support the same operation. Like int and integer basically support the same operation. You know, num being the group, the way to group int and integer that basically support the same operation. Fractional being a way to group float, and double, that a decimal number that support the same operation. So very quick, we can run this through our REPL. Let me just make sure I clean up the REPL. So we do type, what's the type of 5? And then we get exactly that. And we ask what's the type of 3.4. So we get that. Are there questions on this aspect? We're going to come back to type classes and what we can actually do with them. So I would say no. So very quickly, let's jump over operations. You know, here we have the plus operation. It does what it means. It adds like, you know, numeric types. We have the product operation, which multiplies numbers. We have the fractional, which divide to a fractional type. You remember fractional, then being like either float or a double. And then we have the minus, which does what it sounds like. It subtracts the second value from the first value. So these operators are basically function. So plus is a function that takes you know, two values and return another value. And it's the same for product, fractional, minus. Modulo is actually a function that takes two numbers and figure out what's the remainder of the division, you know, of them, like the first one divided by the second one, and it figure out like the remainder and return it as a result. We do have some comparison operators. We did use one of them, which is equal, to compare things that are similar. We have smaller or equal, we have superior or equal, and so on. So these are all comparison operator, and they all take two values and return, a Boolean in this case, which is either true or false. So something Haskell does is inference. So when you get in and you start like defining variables, Haskell, assigning value to variables, Haskell try to figure out like what type they have if you haven't like specified the type in advance. So in this case, for example, we're trying to run this operation where we are defining the value of x, and we are adding 5.2 to 8, and then we ask the type of x, and Haskell tells us it's a fraction of a. So because one of them is already floating point value, and Haskell gets the highest type possible. And again, we will come back to these type classes more in detail. But inference is really the process of the compiler helping you when you write code and you don't specify what the type is. The compiler does help you by providing a type. And very quick on this one. Share my report. So let's say we have calculate sum. So we want to calculate, let's say, the sum of two numbers, and we say you have type, you take, we don't give it a type, in this case, we don't give it a type. We just say you take like a value and you take another one, and then what you return is the sum. So let me fix this over here. That's 2. So we have this function here that basically take, two values, val1 and val2, and return the sum of those two values. So if we go back here in the shell, since we've already loaded this file, we don't have to reload to load it. We just have to reload it. So since it's already in memory, it doesn't like that. So what's the problem here?
I think it's the same as before. You have to move it to the left.
Yes, that's right. So again, happens all the time. There was a space there, and the syntax of the Haskell, the syntax doesn't allow that, because it sees this as something that is defined within the previous function, or they're equal. So if we go back here and we reload, it should all work. So it's telling me that it's compiled. And here what I can do is I can call that function by typing its name. So I start typing and I hit tab, and there it is. So I can give it two values, 2, 3, and I get that. But more interestingly, if I try to figure out the type of my function, I get this generalized type, because Haskell is like, okay, you gave me a function that sums two things, but you don't give specific types for these two things. So I'm gonna have to infer, what it is. And when Haskell does inference, it tries to give the biggest container possible for the value. So You know, we could have done something like this here and be more specific and say it has type integer. It takes another integer and it returns an integer. So at this point, Haskell, if we rerun this in the shell, and then we ask the type. So I just use my direction keys to go back to what I already typed. And we do that. Now we get a specific type, a concrete type. Any question on that?
Yeah, I have a question for you, Manfo. Like when you're like that, the type that you just developed, is there a structure for that? Because you use the dash and the arrow to say, okay, you know, take integer 1, take integer 2, and then return an integer. Is that like a structure for kind of a sum? I'm not sure if I'm asking.
Yeah, you mean here, right?
Yeah.
Okay. So, you know, and we're going to get to this, but in general, anything in Haskell must have a type, right? If you don't give it a type, the compiler will do it. And this is one of the greatest benefits of Haskell because you are literally playing with types like Legos. So if something ends up where it shouldn't be, where it doesn't fit, you know, the compiler will tell you, no, I'm expecting this type here. So this syntax here, where you have, you know, this type, and then you have that arrow and that type, it's basically like a way to define or declare the type of a function.
Okay.
And the last thing you have on this side is actually the return value. And everything you have over here is actually the values that are passed to the function as parameters.
So how do you distinguish between the values that are passed to the parameters and the return value? So let's say I wanted to do, you know, val1, val2, val3, and then return a value.
Okay, so then you will have val3 here, you know, those three. And at that point, knowing that anything that comes before the last type is actually the type of this parameter. So if we have 3 here, we have to have 3 there. Does that make sense?
Yeah, I think that makes sense. So you don't add it. So anything, I think what you clarified for me is anything that comes like before the last return value arrow is kind of a part of the, you know, the inputs.
Exactly. Well, let's see it like that for now. It gets a little bit, you know, complex, but for now, I think that that's a pretty good way to understand.
Okay.
Okay, so do my usual thing. Go back to here. So now we just talked about Boolean values, Boolean types, you know, and they have 2 possible values, true and false. We talked about character types, and we call them char in Haskell, and you can use them to represent any character, the alphabet, digit, character, and so on. We did talk about number, int, integer, and so on. And those are basic types because, you know, when you get to the real world programming, the programming thing, something you're faced with usually is to a way to group things, similar things, and list is what you use. So, and so a list, we can talk about a list of Boolean, meaning the value will be either true or false. We can talk about a list of characters. You know, they could range from A to Z, capital, lower, digit 1 to 9 and so on. We could talk about a list of people. That would include, you know, a new data type that we construct called person, and we can make a list of it to hold like multiple people. You know, a lot of programmers are faced with this problem on a daily basis. So the first one is string, and in here, what I really want to focus on is just to, you know, tell you that a string is basically, well, let's go back to the syntax first. So list, let me switch my screen real quick. So let's say we want to group a list of numbers or something like that, and specifically integers. Then we would go my list equal, and the construct would be something like this. So I could go 1, 2, 3. Then obviously I can specify the type as it's a list of integer. So what you really need to, you know, focus on here is, you know, these brackets. You know, so within this bracket, you can actually define the type that you want. It could be really anything. And I think when we define this calculate sum, so I'm gonna put it there. Without this type, the specific type, and we type into the console to figure out like the type, this is what we got. We got exactly that, which means that, you know, A is a type variable. It could be anything as long as it's a num, you know, or it has an instance of the num class, and we'll come back to that. So lists are really also a way to specify things like this and say, like, you know, I have here a list. That could be a list of anything, but we will get to that. But the key points to take away from here is this is the way I assign a list of a given type of items to a value. And this is how I specify the type of my list. So the construct of the list is these braces. If we go back here, you know, just for demonstration, let me clear up my record. So if I do here the type of if I do here my list, I will define it in there directly equal. So this time I'm going to use characters. So A, B, and so on. So now if I try to figure out the type of my list, that's what I get. So it's literally a list of characters. Are there any questions there?
Yes.
Do you have? I'm sorry. Go ahead.
Okay, thank you. I was going to ask, can you have a list of multiple types?
That's actually a really good question, Axel. In Haskell, I forget that detail. It's definitely not possible to have a list of, you know, different things or different types. So to illustrate that, I can have a list of, let's say, chars and, for example, integers. The compiler will tell me that, hey, look, I don't get this. the list is, what's the word, homogeneous, if that makes sense. So if we go back here and we try to define something like this, where we have 2 here, and then we get into trouble because what's actually happening is the compiler is trying to infer the type of 2, and it figure out like, it's a little bit complicated. It has something to do with type classes, but it tried, but it realized that there's no match with these 2 types, that's being a character, that being a numeric value. So that's not possible. Great point, Axel.
And Manfo, while you're there, where you have my list equals 1, 2, 3 down at the bottom there, that type. So you have to specify an integer there, that it's an integer, or some type of type, or would.
Yeah, I don't have to, but if I don't, the compiler will try to figure it out.
Okay.
And it will probably give me something like this, like, this is
okay.
what we'll get.
Okay.
We'll get something like this instead, if I don't specify anything there. Does that make sense? Because that would be like the highest container possible. 1, 2, 3 being known, so they could be integer or they could be int.
Okay.
Yeah.
Okay, I have a really basic question. What's the difference between the white screen and the black screen?
Good point. So the white screen here is basically a file. So just a file like you and I know it. And I could use Word or any text editor to write this file. As long as I give it this extension .hs, I write my program or my software, my code or solution to whatever I'm trying to solve in there using Haskell syntax, vocabulary, and following like the rules. And once I have this file, this black screen here, let me just make sure. So this black screen here is actually my terminal window. So it's just a way to communicate with the computer. And since I have a file on this side with the content that I want to run or execute, first of all, I need to activate the Haskell compiler. So I need to load up the Haskell compiler that actually look at this file and see if it makes sense in terms of like the rules and the construct of the language. So in order to do that, I do a GHCI, and you see it takes me into this window where I can actually load up this file. I can load up this file over here. And once I load up this file, I have access to all the functions and all the variables that were defined within this file. And I can execute them. Does that help?
Yes.
Great. So very quick, let's go back here. So we did talk about like strings, string just being like a list of characters. So the way you define strings in Haskell is this time, instead of using like a single quote, you have a double quote, and obviously you have multiple characters in there. So a string is just like a bunch of characters defined within like double quotes. So if we try to figure out the type of that string, we get a list of char. And a list of char in Haskell is equivalent to string. So you can either use string as a type or a list of characters. Okay. So we did mention this, that in order to generalize, you can have these brackets, and you can have anything in there. You know, it could be int, could be integer, it could be float, could be even your own custom types that you build, you define, and we will get to that. So we do have some operation on list that are worth taking a look at. And let's talk about the first one. So reverse, as you can see there, we have a list of characters. And what the reverse function will do is it will take in this list and reverse the order. So the last one, as you see, becomes the first one. That one becomes the second one, and so on. I think it's pretty self-explanatory. Another classic operation you can have on list is this strange addition, which is basically the way to add to the list. But I want to stress here that the list have to have like the same types. You know, like here we have numeric values, and there we have numeric values, and that works. If I try to add a list of integers with, let's say, a list of characters, the compiler will scream at me. So we do have the head function. What it does is it basically takes a list and grab the first element within that list. So, you know, it gets a list of things and return the first element within that list. Tail takes a list and return like everything except for the first element, so that it returns another list. So if you look here, head, you know, the thing is it returns an element. So its type would be something like a list of integer, arrow to 5. So if I can just, let me make sure I stress a little bit on this. So we have, so if we try to figure out the type of this function call, which is head, you know, what we get is we have a numeric value, you know, like head function has type numeric value, you know, an A, meaning like could be multiple types, but it's constrained by that numeric thing value there. But you see it's an A. So we started with a list of A, and then we ended up with a list of with an A. So if we just do type, and we try to figure out the type of the function head, it takes a list of things, of types, and returns a single element of that type. So I just wanted to make sure that we stress on that a little bit. So if I go back here, you know, same for last. Last takes a list of things and returns the last element of that list. Init takes a list of things and return all the elements except for the last one. Yes. So here is a representation from the book, Learn Your Haskell for a Great Good, and I think it makes sense. So you have here a list of things, each of those representing one spot or one thing. You know, the last functions returns that one element. The head function returns the first element. The tail returns, I mean, it does what it sounds like the tail, except for the head. And init returns everything except for the butt. I can put it that way. So something that we need to be like careful with is calling some functions on empty list. I don't think we've mentioned this. So a list construct, I can define an empty list this way, you know, just those curly braces. Well, I don't know what they call but those braces, bracket or whatever, without anything in there. So calling head in it will give you an error, you know, like usually called an exception in programming language, telling you something is wrong. You're trying to get the head of a list that is empty. So there are more functions for list, which is the length. The length of the list tells you how many elements are in the list. So we have here, for example, 5 elements, so it returns an int representing the length of that list. Another function on list is null. So when you pass a list to null, it will tell you, if the list is empty, it will return true, as you can see here. Now all these instructions are run through the GHC that we've been going back and forth to, but I think they're pretty self-explanatory here. So null will return false if there's any element in the list. I will get true if the list is empty, meaning it has no element. Reverse, we've already talked about it. Take, what it does is it takes 2 parameters. The first one being the number of elements you want to take from list, and then the second parameter being the list, the actual list. So I want to take 3 elements from this list, so we return a sub list, meaning part of the list, and with 5, 4, and 3, just like you are reading there. Take 1 will return 1 element in the list. So you need to be a little bit careful here with the type of take. Take actually has type, you know, it takes an A. I mean, we can just run it really quick here. So if we go there and we try to figure out the type of take, as you can see, it takes an integer, int, which represent the number of elements we want to take out of that list, which is the second parameter, and it returns those elements. So drop does what it sounds like. Drop 3, I'll drop a certain number from the list. So I will drop those 3 and I will keep the rest. If I drop 0, it means I'm keeping all of them. And if I drop more than days in the list, I'm actually dropping the whole list. So what I will get back is an empty list. And again, drop takes an int, it takes a list of things and return another list of things. So maximum, you know, Haskell, one thing about Haskell is being a modular language. You know, a lot of these functions are built into the language, so you don't have to rewrite them. And, you know, in other languages, you have to write all of this by hand, which is a little bit painful, knowing that there are things that we use daily basis. So with Haskell, you get this for free. So I can have a list of things and ask the minimum of that list, and I get 1. It's a little bit of a magic because, you know, the things that you have in here, the only constraint is they need to know how to compare themselves. So taking 2 by 2 at a time, they should be able to say, oh, the first one, 8, is smaller than this. And it sends us back to the notion of type classes that we will see later on in Intel. Same for maximum, we return maximum value of the list according to how elements of these types are ordered. So we know how numbers are ordered. I could have like a list of people here and I'm looking for some sort of maximum that means something for me. Now it's on me to provide a way to compare two people, if that makes sense. Sum does what it sounds like. Product does what it sounds like. So sum just sums all the elements. Product multiply all the elements. As you can see here, when we have a 0, we get 0, obviously, because 0 multiplied by anything gets us 0. Here's an interesting one, ln. And you need to note here that so far we've been calling functions this way. So let me switch back to my repo. So I'm going to go here. So we've been defining our function in this way, and this function, for example, we said that it took let me make sure I have everything on one line, that it took an integer as a parameter, it takes another one, and it returns an integer. So the way we've been calling this function is by using the prefix notation, meaning that you provide the function name first, like that, and then you pass in the values. That variable is not in scope, so I need to load my file. Okay, I have some stuff hanging there. It's telling me that it goes on like this, and just remove that. Second here, and then we'll reload again, so everything seems to be working now. So let me just clear that out. So again, so when we have this calculate sum, we're calling it, or we are executing it, or running it by calling this function in the repo and providing it with parameters. So we put the function name first. That's called a prefix call. But something Haskell does, which is really neat, in my opinion, is instead of putting the function name before the two parameters, you could actually use that symbol and write the name of your function. Just like that. So what would happen is we will get the same result, and that's an infix call. So putting the function in between the parameters. The benefit of this is how it reads, because when I have, let's say, by the way, those dash is a way to create comments in Haskell. So if I have, let's say, a list like that with elements, and I'm trying to figure out whether one, or let's say a given number, is part of that list, there's a function in Haskell called ln, that takes the element of type A, any type. Remember, when you do lowercase with types, it means any type, and then it takes a list of any type, and then it returns a boolean. So this function here, we can just call it in there. Very quick, ln. We're asking ourselves whether one is element of the following list, 1, 2, 3, and we should get through. But if we get there and we have, let's say, 4, which, oops, sorry, made a mistake there. So if we try to ask whether 4 is element of that list or not, we get or false in here. So, but it doesn't read very well. You know, Haskell with its infix style or option, we can write for, you know, with that symbol, ln, and then give it our list 2, 3. We get the same result. Any questions here? No. Okay. So another very important operator on function is this double exclamation point. You know, as you can see, it's type here. Remember, these 4 columns means type. So we call that in the GHC compiler. We're trying to figure out the type of this operator, and we get this back in return. It takes a list of things and return. It takes a list of things, a position, and return one thing. So as you can see here, we have a list of things. We have that operator there, and then we get back 3. 3 being this element here, because the way you count the item in the list, you start with 0. So that's 0, that's 1, that's 2. And so the second parameter here actually represents the position of the element within the list. Any question on this one?
Yeah. So I just want to ask that with what you just showed there, are you able to call out, let's say, 3 different positions at a time, or you have to do them one after the other?
What do you mean, like trying to get 3 elements from the list at a time?
Yes, at a time.
No,
yes, so like
you
instead of you're not able to do that. Okay.
Yeah, you can do that.
Okay, all right.
Yeah, so you have to call this, you know, 3 times, specifying those positions each single time you call.
Okay, all right.
Yeah. Does that make sense?
Yes, it does.
Great.
Thanks.
Sure. So now lists become even more interesting. You know, these are notions that we'll come back to later in one meetup. But you know, you can do arithmetical progressions in Haskell. So let's say I want a list of, you know, 20, the first 20 integers or int. I can just use the syntax with a dot dot, and it will return those numbers from 1 to 20. I can do the same thing with the alphabet, and I will get that. I can even start at a specific position and, you know, give the first element, the last element with 2 dots in the middle, and I get exactly that. More interestingly, I can give it a pattern. I can tell him, hey, look, I want a list starting of integers starting at 2, going through to until 20. But the algorithm or the reason, well, from the first to the second element, I want an interval of 2. So I want to add 2, figure out the next. So what will happen is we'll get 2, 4, 4 plus 2, 6, 6 plus 2, 8, and so on. The same thing applies for, like, you know, floating point numbers, where you give 1, the first one, the last one, and you give a pattern. You know, it goes there, it takes this one minus that one to figure out, like, the spacing between the numbers, and it creates it for you for free. So moving forward, there are other functions here, and I would invite you to take a look at this doc so that you can you know, have a grip on all these functions that are useful for list. List being like the most used type or concept in programming language. You know, once you have a bunch of things that you need to reflect on. very often you use list. So let's get even more interesting when you start thinking about like some mathematical concepts where you have something called set comprehensions. And here you see what's happening here is you have this general expression in mathematics, where here you have the output of your function, which is 2 times x, meaning like if you give me an x, I will multiply it by 2 and you will get the result. And here you have this, you have that bar there, and this is where you are drawing your values, your x values from. And here you have something called a predicate, which is a constraint that you are posing on these values that you will draw. So what will happen? This fits very well with the list type, because when you have this writing, what you will get back is actually a list. So if let's demonstrate this very quick. So go back here to the repo. So let's define this. We say result, or result, which is a variable, equal. We do this, and now we're gonna write our result. So first of all, I put my bar, because on the left side I will put my function. So we said 2 times x. So every time I have an x value, I will multiply it by 2. And on this right side, what I need to tell Haskell is where those x's or x values are coming from. So the syntax for that is this. I'm going to tell him you can draw. So I'm basically drawing. Well, getting my x values from another list, which is, for example, from 1 to let's say 20. So after that, I put a comma, and here I will put something called a predicate. A predicate. A predicate is just something that will run the value and return either true or false. So to be more specific, I can say get the x's from this interval as long as the x's you're getting are not bigger than 10. So what we will expect when we run this, let me just say I'm having some issues with my GHCI to get into the compiler, and I'm going to load this file, the main that we just wrote all the code into. So it doesn't like lm because I gave it a declaration, but I didn't actually give a definition to the function. So I will reload, and this time it's happy. So I'll make sure to clear it up. So if we try to print result, if we try to figure out like the value of result, there you see that what we get is 2 in the first value. So that's the first x that was gotten from here, 1. We multiply 2 by 1, we get 2. Then the second one was 2, so 2 by 2, 4. The second one was 3, 3 by 2, 6, and so on until 10. So let's stop there. Any questions here? How are we doing, guys?
Yeah, good.
Are we sure?
Yeah, cool. You're following through.
Okay. Okay, cool. So now we have a mini exercise here where I will just, ask you very quick, what do you think we will get as a result for this function call? So let me just put it in context. We have a list of things, character in this case. What we want is to filter, let's say, some characters from that list that we are passing in to our function. So that bar there does that. And after the comma here, we have the constraint that every character each character that we take from this list must be an element of that. So my question to you is, what will happen if we run this remove non-uppercase? Well, I think the name is saying it all, but what would happen if we were to give it, let's say, hello world, all in capital letters? Well, let me write that down. Let me just make sure we copy that. Put it over here in the reference. So what will happen if that, given that function, we came here? Can you guys see? Let me just add a break line here so that you can read the whole function. What would happen if we come in here and we try to run this function and we give it, let's say, well, let me do this. We try to run this function by giving it this characters like hello.
That's a question, right?
Yes.
Okay, so let me just try.
If you want, you can write in the thing, you can try it locally. But it's fine if you give the answer directly as well, with some explanation. Mm-hmm.
It looks like I was talking, but nobody heard me. So what I wanted to say is that with that particular function, what happens at the end is that lower cases are being eliminated, and then the upper case are being printed out to us. So you have capital H and capital E as the output.
Yep, that's it. And that's great. I'm trying to go back to my report here. Where did it go? One second here. I'm trying to figure out, like, having some issues here. Okay, There you go. 1 second. Share my screen. Can you guys all see? Can you guys all see?
Yes, yes, I can
Okay,
see.
great. Yeah, so, you know, right there, we got the H, and the E, which are basically what we specify here, that we all want, you know, grab all the elements as long as they are, you know, part of this list. So C must be an element of this list. And given that we passed in the hello string, and all elements of this list are capital, and they go from A to Z, all the alphabetical characters, we will get H and E here. So let's go back to the lesson. So next, we will talk about tuples. Tuples are really a way in Haskell to group types that are, what's the word? Heterogeneous, meaning that different types, like remember how with list, we couldn't add like different types. They had to be like homogeneous. With tuples, we are able to group types that are different. Like the syntax here, as you see, we have like parentheses. We have Christopher, which is a list of characters. And then we have Vulcan in the list of characters or a string. And then we have 55 there, which is an int. So at this point, the compiler will not complain at us. So to demonstrate that, I feel like we should take a quick break. Maybe after this. Okay, let's just wrap up the tuple thing. So the way you declare or define a tuple value is, if we go back here, so I can do my tuple. My tuple. Equals between parentheses, I can do hello. I can do a name here, ourselves. I can do let's say 1989, and I can do something like 20. So again, tuples, the syntax to declare them is with parentheses, and you know you have basically the number of the spot in the tuple are kind of limited, but it's a high number. I don't remember exactly how many you can have there, but each of these has its own type. So we have there a list of characters, we have another list of characters, and then we have 20, which is an int. So every time in your program that you are thinking of grouping things that seems connected, but you don't have yet a structure for them, you can use tuple to handle them. Like here, this case, for example, could be Axel is born in 1890. I know it's not the case. And also he has, let's say he got 20 over 20 in math or something like that. So again, so we can either load up this thing and run this value, it will show us this with the type. So if we go there, we reload the file and then type my with a tab key. We complete that. My tuple, we get its value, and we can ask the type. So the type of my tuple, and we get it a tuple. So a tuple is actually the name of the type, the tuple of characters, list of characters, and integer. So yeah. So very quick, let's do this. Let's look at some functions that operate on tuples. We have a tuple there of integer and integer, or int and int. When we run first and we pass it that tuple, we get 8 back. So it goes in there, just like its name indicates, and grabs the first value. So same thing down here, first of this and this, we get whoa. Second, returns the second function, takes a tuple and returns the second value, in this case 11. So I think we should take a break at this point. And if you have any good questions, please go ahead before we take a break, and come back like in 15 minutes. If everybody, 10 maybe, if everybody is okay with it.
Yeah, so I just want to ask, so this is REPL, but whatever it is that we are doing here, does it work the same when you're using the Visual Studio Code, or there are some slight changes?
So we've been using like pretty much, let me share this and put it into context. So this platform we're using, REPL 8, actually shows us like both aspects. So main.hs is what you would get in Visual Studio, right? So you would have your editor there, you will create a file and name it main.hs, and you'll write your code in here. You will write your functions or whatever. You will declare your types. And then in order to execute them, you will go to your REPL. So your REPL is where you actually run your code, because what's happening in here is we are loading up this main file into the REPL with the load command. And once we load it in there, we have all the functions and everything. We have access to everything we wrote in that file into the REPL. And now I can start like referencing these functions, for example, or that variable or that function. Does that make sense? So
yes.
So with Visual Studio, to finish with Visual Studio, what will happen is you will have, let's say, a folder, a way to organize your code in a very nice way. Or you will type in all of these, create files within those folders. You will type in all of these things, and then as you type them, you can be checking, testing them within like your shell, and making sure they actually work. As a step.
Okay, that's great. Yeah. Thanks.
Any other quick question? Okay, I would say we stop here and come back at 8:17, something like that, and try to wrap this up.